All right, so we're on question number 2, and I'm going to write down what I'm seeing over here. F of x, and again, this is problem number 2. We just completed problem number 1. What's f of x here? It's x4 over 9 plus x squared, and we're centering this at 0. Now, the last problem I did, the way I did it was I saw it as being geometric in form. Now, I also see this being geometric in form, but I'm going to do this one differently and do number 1. So what I'm going to do over here, I'm actually going to do a, let me see if I want to do that. Yeah, I think I am. So I'm going to put down 9 plus x squared. I'm going to do this a little differently, and I'm going to divide that into x4. Okay, so what do you do over? Let's see if we can do that. Yeah, what times, let's see, what times 9 would give you x4? That would be 1/9 x4. And this is another option, by the way. You may like the option because you see divisions being difficult. And what's it going to give you? Well, that's going to give you x4 plus 1/9 of an x6. I'm going to subtract it, and that's going to be minus 1/9 x6. Well, I'm going to keep repeating it, and what do we got now? I have minus 1 over 81. And why is that? Minus 1 over 81 times 9 would be minus 1/9, but I need x6. Now, granted, this is never going to stop, but I'm hoping to see a pattern at some point. So what do you see over here? You would get minus 1/9 x6 minus 1 over 81 x8. You're going to subtract. What do you get? 1 over 81 x8. Well, you know what? I think I see the pattern, but I'll write this down as plus 1 over, well, now it's going to be, let's see, I'm going to say, writing the number down, I'm going to put down 9 cubed x8. Now, if I did that, I hope you realize, one of the 9s, we can't get 9 squared, which is 81 x8. So I think I see the pattern, all right? Now, when I say I think I see the pattern, I'm going to write this over here. F of x equals, let's write this over here, x4 over 9 plus x squared equals, now I'm going to sort of write it down, at least what I'm seeing. I'm seeing 1/9 x4. I'm seeing minus 1 over 9 squared x6 plus 1 over 9 cubed x8 minus, I can think of write the next term down. I'm certainly seeing a 1. And, 9 squared, 9 cubed, 9, 4. And then what do you get over here? X. Well, let's see. It looks like it's going up by 2. 4, 6, 8. So it's going to be 10. And then I can say plus, yada, yada, yada. Now, my goal here is to write down a sum. All right, let's put the sum down. And I'll put this sum over here. And I'm going to start at 0. I'm going to put the 9 at the bottom. And that's going to be 9 to the what? Well, this is 9 to the 1, so I need to put n plus 1 over here. All right? I'm also going to put the x down now. And I got to look at that. It certainly has to do with 2n. But if I started at 0, the reason I say 2n is going up by 2. If I started at n equals 0, that would be 0, so I need to add 4 onto that. I also know it's alternating, so I can put this over here, minus 1. And I want the first term to be positive, so I can just put an n over there. And that's going to go back to be plus or minus. All right, so I'm pretty good with this. I definitely know what it looks like. But what I want to do is I want to do the interval conversions. And the way I'm going to do that is I'm going to use what's called the ratio test. And again, this differs from what we did in the first problem. First problem, I used a known series to get it. Now I just generated it by using a long division. But I can use the ratio test. It's going to be the limit as n goes to infinity. Now let's write this carefully down. So it's minus 1 to the n plus 1 times x, well, it's going to be 2 times n, still 2n, plus 2 plus 4 is plus 6. What goes in on bottom? That would be 9, n plus 2. I'm going to divide by that term, but it's like multiplying by its reciprocal. I'll put this over here, 9 to the n plus 1 over minus 1 to the n. and x to the 2n plus 4, absolute value. Let's simplify that. That's limit as n goes to infinity. And you know, noticing the minus ones, the absolute values of those are just 1. But if you wrote it down, it's really minus 1 to the 1, which is minus 1. But the absolute value is 1. Now let's look at the x's next. All right? So I want to point out what I did over here. Kind of looking at it, you know, this over here, again, if I just simplify that, you know, it's minus 1 to the first power, which is minus 1. But the absolute value, that's 1. Now I'm going to move on to this. And what would that give you? Let's see. That would give you 2n plus 2. I'll write that down now. I'm sorry, not 2n plus 2. What did I say there? I was looking at that saying, that looked really strange. I don't get 2n plus 2. The 2n's disappear. What do I get? I get x squared. Sorry about that. Right, and then I'm looking at the 9s, and what do I get? I just get a 9 in the bottom. All right? And what's supposed to be over here, the limit, it's nothing to do with n at this point. It's x squared over 9, and I want that to be less than 1. Now what does that mean? It means that x squared is less than 9, which means the x is between 3 and minus 3. All right, so we just used a ratio test to get that. And as you probably know in the ratio test, what I got to do is I got to plug in the endpoints now. So let's do that. And where do I plug it in? Right over here. And let's do that now. So what I'm plugging in, x is 3. So what do you get over here? You can get the sum, n equals 0 to infinity, minus 1 to the n. And then I'm plugging in 3. And what are you going to get there? Well, let's write that down. It's going to be 3 to the 2n plus 4. And what goes on the bottom? That's actually going to be 3 squared. So that's going to be 3, and it's going to be 2n plus 2 now. Let's keep moving. What do you get over here? N equals 0 to infinity. And what do you get there? Minus 1 to the n. And if I did that, I just get, you know, looking at just 3 squared, which is 9. And this is definitely divergent. I would not include that. Let's do this one over here. Again, you might say, do I need to do that? Well, we're just learning. And it's a good idea to check endpoints, unless you're absolutely sure they shouldn't be included. And what do I put down? That's going to be minus 3. Whoops, this is to the n over here. 2n plus 4. And the bottom is going to be 3 to the 2n plus 2. Let me simplify that. And, you know, a little more complicated, isn't it? N equals 0 to infinity. This is going to be minus 1 to the n. That's going to be minus 1 to the 2n plus 4. And that's going to be minus 3. I'm sorry, not minus 3. Sorry about that. It's like daydreaming there. It's going to be 3 to the 2n plus 4 over 3 2n plus 2. I'm going to continue to simplify that. N equals 0 to infinity. I'm kind of looking at this is still there. And this over here is always going to be an even power minus 1, so that's just simply 1. So I'll write that down now. So it's going to be minus 1. Oops, maybe I shouldn't do that. So I'm seeing minus 1 to the n. And this, you know, the 3n plus 4 divided by 3n plus 2 is just going to be a 9 again. So what do you know about this one? Also divergent. So I'm not going to include those points. So let's summarize, and I'm going to write this down now. x4, 9 plus x squared is equal to the sum n equals 0 to infinity minus 1 to the nth power over 9 n plus 1 times x to the 2n plus 4. This is one thing they wanted me to do to get a series. The other thing is to put down the radius. Well, looking at the radius, I'm looking at this over here, that a radius of 3. And the interval, I, is going to be from minus 3 up to 3. That's where it converges. All right? Again, my recommendation is look at the answer keys provided in the document that I'm providing to you. You know, am I seeing this business over here, which is n equals 0 to infinity, you know, minus 1 to the n, and the bottom is, yeah, I'm seeing that. Yeah, I'm seeing everything there. Am I seeing this? I am. And am I seeing this? I am. Everything's working out as advertised. Thank you.